welcome back to Statistics and Probability class. In life, there are events which will certainly happen, while there are probable to happen, or some will definitely not happen. If we are not certain of the events or answers to questions, then hypothesis testing is considered. Hypothesis is a proposed assumption about a population parameter. Hypothesis testing is a method in statistics used in decision-making given experimental data. It is basically evaluating claims or assumptions that we make regarding a population. Its two types are null and alternative hypothesis. Null hypothesis, denoted by H sub 0, is a statement showing no significant difference between two parameters. You may consider it as a current value of population parameter, which you wish to disprove in favor of the alternative hypothesis. On the other hand, an alternative hypothesis, denoted by H sub A, is a statement showing significant difference between two parameters or between a parameter and a specific value. Example 1. Based on a survey, the average weekly internet usage among senior high students of Masigasig National High School is 21 hours. Myra, a senior high student in the school, would like to find out if the claim is true among her classmates. She tests if there is a significant difference between the time spent on internet by her classmates and by senior high students in the school. For the solution, let mu be the population mean time or the average weekly internet usage of senior high students of Masigasig National High School, and let x bar be the mean time of Myra's classmates. The parameter or the numerical quantity characterizing the given population in example 1 is the average weekly internet usage of senior high students in Masigasig National High School, which is 21 hours, or that is mu equals 21 hours. Hypotheses may then be written in either of these ways. H sub 0, or the null hypothesis, be the statement the average weekly internet usage of senior high students of Masigasig National High School is 21 hours, or mu equals 21. H sub A, or the alternative hypothesis, be the statement the average weekly internet usage of senior high students of Masigasig National High School is not 21 hours, or mu is not equal to 21. Or, we may also write them this way. H sub 0, or the null hypothesis, be the statement the average weekly internet usage of senior high students of Masigasig National High School has no significant difference with the average weekly internet usage of Myra's classmates. In symbols, that is H sub 0, colon, mu equals x bar. Or, H sub A may also be written this way. It is the statement that the average weekly internet usage of senior high students of Masigasig National High School has a significant difference with the average weekly internet usage of Myra's classmates, or in symbols, that is H sub A, colon, mu is not equal to x bar. So let's have example 2. The average price per square meter in building a house is above 10,000 pesos. Philip wants to test the contractor's claim. Write the null and alternative hypothesis. For the solution, the parameter is the average price per square meter and the claim is above 10,000 pesos. This claim in symbols is mu is greater than 10,000 pesos. It uses greater than symbol, making it fall under alternative hypothesis. The null hypothesis then is less than or equal to, being the complement of alternative hypothesis, which in this case makes use of greater than symbol. That is, H sub 0, or the null hypothesis, be the statement the average price per square meter is at most 10,000 pesos. Or H sub 0 be the statement, the average price per square meter is 10,000 pesos. Or H sub 0 colon mu is less than or equal to 10,000 pesos. Or H sub 0 colon mu is equal to 10,000 pesos. Okay? So we may express the null hypothesis of example 2 in either of those ways, or of these ways. Next, H sub A, or for the alternative hypothesis, the statement is the average price per square meter is above 10,000 pesos. Or H sub A colon mu is greater than 10,000 pesos. And alternative hypothesis in example 2 is the claim. Let's have example 3. A barangay official of a certain geographically isolated barangay claims that the average monthly income of families in his area is at least 6,000 pesos. A random sample of 20 households from the area has an average monthly income of 5,900 pesos, with standard deviation of 200 pesos. What are the null and alternative hypotheses? For the solution, parameter is the average monthly income, and the claim is that the average is at least 6,000 pesos. This refers to the greater than or equal to symbol, which means that the claim this time is at the null hypothesis. Hence, the alternative hypothesis will use less than symbol as the complement of null hypothesis. That is, H sub 0 or the null hypothesis, colon, mu is greater than or equal to 6,000 pesos, or H sub 0, colon, mu equals 6,000 pesos, which is the claim. Now, for the alternative hypothesis, we have H sub A, colon, mu is less than 6,000 pesos. Okay? So this time, in example 3, we have written the null and alternative hypotheses in symbols. As you can recall, in examples 1 and 2, we have written the null and alternative hypotheses both in symbols and in words, or both in notations and in words. Now, what is level of significance? Level of significance, denoted by Greek letter alpha, refers to the degree of significance serving as basis on whether to accept or reject the null hypothesis. It is the probability of committing wrong decisions for a null hypothesis that is true. The most common levels of significance are 1%, 5%, and 10%. So let's have example 4. Cherry uses 5% level of significance in proving that there is no significant change in the average number of their school's senior high enrollees for first and second semesters. What are the chances that she would have a wrong conclusion? For the solution, the chance that Cherry's conclusion that there is no significant change in the average number of senior high enrollees of the school for the 2 semesters is wrong is 5%. That is, the chance that the null hypothesis would be rejected when it is true is 5%. An alternative hypothesis does not only show its prediction on the difference between the sample mean and the population mean, but also how it differs in a specific direction, either lower or higher. And this test is called as directional or one-tailed test, where the rejection region is on one tail of the distribution. Alternative hypotheses of one-tailed test may contain greater than or less than symbols. It may either be right-tailed or left-tailed. However, some hypotheses show prediction on only one value being different from another, without mentioning which will be higher. This is called as non-directional or two-tailed test, where an extreme test statistic in either tail of the distribution will result to the rejection of the null hypothesis, stating the absence of significant difference. Its alternative hypothesis contains inequality symbol and it has no direction. The table states the null and alternative hypotheses involving the directional test. Let us go back to the examples. In example 1, the phrase "if the claim is true" has no clue of the direction of the test. Hence, it implies either higher or lower average weekly internet usage. And this shows a two-tailed test. That is, in notations, h sub 0 colon mu equals 21 and h sub a colon mu is not equal to 21. And that is two-tailed test. Example 2 used the phrase above 10,000 pesos, and that is associated with greater than symbol. Hence, it is a one-tailed test. Specifically, it's a right-tailed test. That is, in notations, h sub 0 colon mu equals 10,000 pesos or h sub 0 colon mu is less than or equal to 10,000 pesos. And h sub a colon mu is greater than 10,000 pesos. And this is a right-tailed test. Nevertheless, the hypothesis in example 3 used the phrase at least 6,000 pesos. And this is associated with greater than or equal to symbol. Therefore, it is again a one-tailed test. That is h sub 0 mu or h sub 0 colon mu is greater than or equal to 6,000 pesos or h sub 0 colon mu equals 6,000 pesos. And h sub a colon mu is less than 6,000 pesos and thus it is specifically a left-tailed test. The rejection region or critical region refers to the set of all values of the test statistic serving as basis for the rejection of the null hypothesis. On the other hand, non-rejection region or acceptance region refers to the set of all values of the test statistic serving as basis for the acceptance of the null hypothesis. Furthermore, the critical value is a point or boundary on the test distribution that is compared to the test statistic to identify whether the null hypothesis is to be rejected. Let us take a look again at example 3. A barangay official claims that the average monthly income of families in his area is at least 6,000 pesos. And that is h sub 0 or the null hypothesis, where mu equals 6,000, x bar or the sample mean is 5,900, sample standard deviation or small s is 200, and small n or the sample size is 20. Now since n, the sample size, is less than 30, then what we need to compute is the t value. That is t equals x bar minus mu over s divided by square root of n. And by substitution, we have t equals 5,900 minus 6,000 over 200 over square root of 20. Now, using your calculator, we have t equals negative 2.236. Then, from the t table, identify the critical value. Use degree of freedom or df equals n minus 1. That is, df equals 20 minus 1, hence df equals 19. And then use df equals 19, use one-tailed test at 5% significance level. Now, the critical t value is 1.729 if we locate those data using the t table. But since earlier, we have determined that this is particularly a left-tailed test, then critical t value becomes negative 1.729. And this is the illustration for that. us refer to the table beside me for easier understanding purposes. H sub 0, or the null hypothesis in words. This is stating or formulating the null hypothesis in words. We have the average monthly income of 20 households is the same as or greater than the entire barangay's average monthly income. Now, H sub A, or the alternative hypothesis, is a statement: the average monthly income of 20 households is less than the entire barangay's average monthly income. The computed t-value is at the rejection region. We reject the null hypothesis H sub 0 in favor of the alternative hypothesis H sub A. Now, type 1 error is committed when a true null hypothesis is rejected. It has a probability denoted by alpha, hence the rejection region or critical region is called as the alpha region. Whereas type 2 error is committed when a false null hypothesis is accepted. It is denoted by Greek letter beta, and the acceptance region is called the beta region. Let us have an example. Let's have example 5. Crisanta is deciding on which university to enroll. She wants to conduct a survey on the licensure exam passers of various universities and test at 5% significance level whether or not the percentage of passers is high enough before she selects a university. She will only choose the university if there is a strong evidence that the percentage of licensure exam passers there is high enough. We can state the null hypothesis for her test as H sub 0, the percentage of passers is high enough. That's the null hypothesis. Type 1 error may be committed when Crisanta does not select a university where percentage of passers is actually high enough. It is type 1 error since she rejected the true null hypothesis. On the other hand, type 2 error may be committed when Crisanta selects a university where percentage of passers is not actually high enough. It is type 2 error since she accepted the false null hypothesis.
Example 6. We have here two statements, and for each we have to give the null hypothesis and the alternative hypothesis both in words and in notation, and we also have to give what kind of test should be used. For the first statement, we have the average number of learners in a section is more than 35. So we'll give the null hypothesis and the alternative hypothesis. Let us begin with the null hypothesis. It can be the average number of learners in a section is 35 at most, meaning that can be less than or exactly equal to 35. And the alternative hypothesis will be the same as the given. The average number of learners in a section is more than 35. And in symbols, that is, the null hypothesis is the average is less than or equal to 35. That is what is meant by 35 at most. And the alternative hypothesis, the average is greater than 35. And since it is greater than, then it's one-tailed to the right. For the second statement, we have Mr. Carlos says that on the average, there are 15 working students in the classes he handles. The principal wants to verify whether the claim is acceptable or not. To begin, let us have the null hypothesis. It is the average number of working students in Mr. Carlos' classes is 15. That is a claim of Mr. Carlos. And of course, the alternative hypothesis is that the average number of working students in his class or Mr. Carlos' classes is not 15 or not equal to 15. And in symbols, that is the null hypothesis, average is equal to 15, and the alternative hypothesis is that the average number of students is or working students is not equal to 15. And since it's not equal to 15, then we do not know if it's left-tailed or right-tailed. So we'll be using both tails. So we'll use two-tailed test for this statement. Example 7. If the critical t-value is 1.376 and the computed t-value is 1.235, then the computed t-value is at the rejection or acceptance region. So we'll select one from these two. So first, let us consider this figure. Suppose this is the t-distribution, then the given are located here, the critical t-value which is 1.376 and the computed t-value which is 1.235. It is to the left of the critical t-value because it's less than this positive t-value or critical t-value. And so since this is the critical t-value, then the rejection region will be this shaded part. And the acceptance region is the area under the t-distribution minus this shaded area. So this whole is the acceptance region, including this part where the computed t-value is located. Now, since the computed t-value 1.235 is not part of the rejection region but is part of the acceptance region, then our conclusion is the computed t-value is at the acceptance region.
With the bulk of things you have learned today, I hope you will be able to apply them in the next lessons. Until next time!